In today's session, we're going to spend some time working on equations with decimals. As you recall, we're going to solve these the same way that we solved equations with integers or whole numbers. We do have to watch out for our decimals, and of course we have to watch out for our signs. Let's get started. When I see a subtraction equation, I know that I need to do the inverse operation, which is to add. In my opening statement, I said that we need to be sure to line up our decimals. So I'm going to be adding 4 and 27/100ths to both sides. It cancels and eliminates on the left, and then I'm adding here on the right. I put a placeholder, not necessary, but just so that you see that your place values are lined up as well as your decimals. Your answer is the value of x is 8 and 17/100ths. On to the next problem. Subtraction again, so we will add. In this problem, after I've lined up my decimals, I notice that it eliminates on the left, but I also want to draw attention to the fact that I'm now adding a positive and a negative number, which means I need to subtract and keep the sign of the greater absolute value. And my answer is x is equal to negative 9 and 3/10. I have a negative 6 and 7/10 added to x, so I'm going to add it to both sides. This problem, once again, has unlike signs. I need to subtract and keep the sign of the greater absolute value. I also have to rename or regroup this because I don't have enough in the tenths in order to subtract. And I get a negative 4 and 5/10. Let's move on to our addition equations, which require us to do one inverse operation here, and that's subtract. The rules of subtraction are to add the opposite, and sometimes we need to apply that, and being basically here for the larger numbers first, I can just go ahead and subtract, and I get x is equal to 6 and 3/10. If I wanted to check that, I could just place that back into the original equation, substitute the value of x in, and then add it to see if it comes out, and it does. So once in a while you might want to do a check. Let's do another addition equation where we must inverse and subtract. In this problem, we'll see that they need to definitely add the opposite because I had unlike signs there. And when I do that, it becomes now negative 5 and 1/10. So I have a negative plus a negative, which gives me a negative 11 and 5/10. Let's subtract again. When I line up the decimals, I'm also lining up all the place values. And this one tells me that I need to add that 0 here because I can't take this 3/100ths from 0/100ths, so I need to do another bit of renaming or regrouping here. Remember, I'm subtracting. And I get x is equal to 5 and 37/100ths. And if I took that to add it back, I'd get the same answer. Moving on to our multiplication and division equations. These three are divisions. X divided by 4/10. What will we do? The inverse will multiply both sides by 4/10. In multiplication, we do not need to line up our decimals, but we do have to count them up at the very end. So when I look at a problem like this, I'm going to treat this like multiplication and deal with the decimals at the end. 6 times 4, 24. The 4 times 3 is 12, plus 2 is 14. I have 2 decimal places in the first factor, 1 in the second. I need 3, counting from the back, 1, 2, 3. And x is equal to 144 thousandths. Next problem again is division, so I am going to, I'm going to multiply. And I'm going to deal with this one digit at a time. 7 times 2 is 14. 7 times 5 is 35, plus 1 is 36. On to my second row. 3 times 2 is 6, and 3 times 5 is 15. Add up those subproducts. On to the decimals. I see 1 decimal in the first, 1 in the second. I need 2 in my answer. But before you move on, notice that you are multiplying a positive and a negative, so your answer to this is a negative. Negative 19 and 24 hundredths. The last problem on this slide, we're taking 62 and we're multiplying that by our 14 hundredths. 4 times 2 is 8. 4 times 6 is 24. Our second row times 1, and then we add our subproducts. We need 2 decimal places in our answer, and there you have your division equations with decimals. The very last ones we're looking at today are the multiplication equations, which require us to divide. Now I'm keeping our numbers nice and low so we don't need a calculator, we just need to review the skills. It's very important to show all this work. We have 14 and 1/10 divided by 3/10. On homeworks, on quizzes, on classwork, please show your work. We want to remember that the divisor should be a whole number, so we're going to multiply it by 10, which means we're moving the decimal over once. And then I tend to put it up in the quotient because sometimes we have to add extra zeros. We'll now do the division. 3 into 14 will go 4 times, which is 12. You subtract and bring down your next digit. 3 times 7 is 21. We see my remainder is 0. So x is equal to 47. We're going to divide each side on the second problem by 4 hundredths. Let's take this and rewrite it. We have a negative 724 thousandths divided by 4 hundredths. Right away I noticed this negative, and the signs are unlike. I'm going to put my negative right up in my quotient so I don't forget. This requires me to move my decimal over twice to make it a whole number. I do the same thing on the inside. And now I can go ahead and divide. I have 4 into 7 will go once. I subtract, bring down my next digit, which is 2. 4 times 8 is 32. I'll subtract and bring down my next digit. And then I have 4 times 1 is 4, remainder 0. So x is equal to a negative 18 and 1/10. I hope this is getting easier with each practice problem. Last problem of the day. We're going to take each side and multiply it by 1 and 1/10. So I have 68 and 42 hundredths divided by 1 and 1/10. Again, your divisor is a decimal, so we're going to move that over to make it a whole number. Whatever we do on the outside, we do on the inside, and place it right up in the quotient. Now it's time to divide this number by 11. Well, it'll go 6 times into 68, and we'll subtract and bring down our next digit. 11 times 2 is 22, and we'll subtract and bring down. And one last time, we'll get a 2, remainder 0, and we'll see that x is equal to 62 and 2/10. Keeping these numbers again reasonable so that you can do this computation without the use of a calculator. And I hope that was helpful.